In this video, we'll discuss about parametric functions. See, last video you have discussed about exponential and logarithmic functions, correct? Now, in this one, we are going to discuss about the parametric function. See, you need to understand what do we mean by parametric function. In other words, the actual question should be, what exactly do we mean by a parameter? Alright, because if you understand the meaning of the word parameter, then parametric function is going to be very easy to understand. See, to understand what are parametric functions and what is a parameter, okay, if you remember, last year you have learnt about vectors, if you remember, right? So whenever we are writing vector, you had something called as resolving of vectors or writing them as their components, right? Now, suppose if you have a vector A, some vector A, then we write the x component as A cos theta and y component as A sin theta. Now, why all of a sudden I'm talking about vectors is because you guys need to understand what exactly we mean by a parameter. Now, here, if you see these two, AX, see, AX is a vector, correct? A component of a vector. But a component of a vector is represented in the form of theta. In the sense, there is some other variable, some other parameter which is defining the function, correct? Now, AX being a vector is defined by another parameter, what we call as theta. So here, theta becomes the parameter. So parameter is that variable which defines the function. Make sense? So in this case, for AX or AY or in this vector where you resolve into its components, theta becomes the parameter. Now there are different types of functions. Okay, now whatever the general functions what we see, they're all Cartesian coordinate or rectangular functions we call it. In the sense, you can say f of x is equal to 3x square plus 2x plus 1. Now here f of x is nothing but y value. So you substitute a value for x, you will get a value of y. You can make a table and plot this on the graph, whatever, right? Now these are type of functions which can be plotted on the graph, alright? Now there are other types of functions also. They are what we call as polar functions. So polar functions are those which is represented in the form of r and theta. Now, last year you had something called as complex numbers. That was one of the chapters. In that, you had polar form in terms of r and theta. So one was the normal form, which is x plus iy. One more in the form of r and theta. So we had two of them, right? Now, r and theta is the polar form. That means the same function f of x, you are presenting it in terms of another parameter, which is r and theta. So, parameter is that variable which defines the function, but the same definition of the function will be given in another format, like with the help of another parameter. This is what we mean by parametric function. Alright, now let me show you different examples. In the next one, we'll see how to solve it and all. But let me give you one simple example. Apart from this vector, what I have discussed. Alright, see, now what we have, assume that you have a function, say x is equal to r cos theta, y is equal to r sin theta. Okay, it's pretty much the same as vectors itself, but a little different. That's all. Now you have r cos theta and r sin theta, right? The two variables x and y, we are representing them in terms of r, which is one parameter, and the other parameter is theta. So we are representing the rectangular coordinate system in terms of polar coordinate system, which is r and theta. See, this is an example. All right. Now, to differentiate these things, okay, to differentiate, because whenever we look into it, always, what do we say? Dy by dx, correct? What is the value of dy by dx? But here, x is another function of theta. Y is also another function of theta. So how do we do dy by dx? Isn't it? This is the next part. Now, in the next video, I will show you how to solve it with couple of examples, and then we'll start looking at solving problems.